But the reality is there is no such big clock on the sky, right? To measure the sequence of these events, you need to be the person at each one of them. You need to be the person traveling in the rocket or sitting on the planet or sitting at the black hole. And what you see on your watch will differ depending on where you are and which of these events you're at and how you're traveling through the space and the time. And that is, as I say, very counterintuitive, but it is really how our universe works. The second thing that you need to know, and this is, again, it's probably deep in you because it's one of the first things you learn when you're at school. Like, I think really the first science lesson you have to learn forces, and you learn magnetism, and you learn gravity. So you say, name a force, and you say gravity, but that's wrong. Okay, we shouldn't actually teach children this. I actually think we should just teach them space-time curvature directly, but I'm apparently a minority view here. Yeah, we teach them it's a force, which is okay, works on the surface of the Earth. But what is a force? So the idea of a force is that it's something that changes your speed or direction. So in this picture particularly, I'm thinking about a change of direction. So I'm flying my spaceship past a planet, and it gets somehow pulled off course by this gravitational force. And, we think of this as being like, a kind of like a big magnet that sort of attracts the spaceship towards the Earth. But what I want to tell you is that that's not what's really happening. So in fact, we would say actually that there is no change of direction. So the picture that we should have is something like this, that it's not a force that's pulling us off course, it's space-time curvature.